All right, let's get started. Good morning, everyone. I'm Alex Maros. I'm a product manager with Route 53 team, and this is a session on AWS Cloud Map. Thank you so much for coming today, this beautiful Friday morning after that big party. And it's amazing to see the full room here. Thank you so much, guys. You're amazing. So let's get started. Today, we're going to talk about a few topics. So why we built AWS Cloud Map, the service that we launched a couple of days ago, and I hope you had a chance to look at it, familiarize yourself. I'm going to discuss the key use cases that we support, and of course, we support more use cases, and I would be happy to chat with you guys after that session. We're going to have a Q&A, obviously, to learn about your use cases and understand how we can help you build more resilient applications faster. I will talk about ecosystem, and we have an exciting guest today. That's absolutely amazing to have this guy here with us. It's really exciting. I'll keep it till we go to the ecosystem part. Then we'll briefly touch on availability and pricing for this service. And of course, I hope we're going to have time for Q&A. We will address all the questions that you have. All right. So first of all, why we decided to build AWS Cloud Map. And primarily that's because in modern applications, we use a wide variety of resources. It's not just EC2 instances anymore. It's much more than that. You have your microservices that run in your ECS Fargate, maybe. You have your EKS running. You have your cloud storage. You have your cloud databases. You have queues. You have a lot of different services, a lot of different resources to connect to. And the complexity grows really exponentially with the number of components in your system. It becomes really tough to manage all your components in configuration file, let's say. And more than that, we do have multiple versions. We do have multiple deployment stages. And it's getting bigger and bigger and bigger and more difficult to manage. On top of that, we deploy our applications on the infrastructure that scales dynamically with load, which is yet another dimension of complexity that we want to address with AWS Cloud Map. And of course, with all these dynamic resources, some endpoints sometimes go down, they're being replaced. And you most certainly want to stop routing traffic to your unhealthy resources and just make sure that healthy stuff gets discovered so your applications, keep running, even if part of the endpoints fail. So the way to address all that complexity, we call it service discovery. And on a very high level, it's the ability to find the location of a service provider. As simple as getting a resolution of your name, my app, that can resolve to a few endpoints, or maybe my logs that can resolve to a few S3 buckets where you store your logs, something like that. And there are two general patterns in service discovery. The first one I want to touch on is server-side service discovery. We know load balancers. We use load balancers. That's an amazing tool. So you get your load balancer, and the discovery problem is abstracted away. Your applications just need to know the endpoint of that load balancer. But all the connections, of course, are proxied, and you add a bit of a latency with load balancers. For many customers, that's not really desirable in some use cases, so there is a different pattern, client-side load balancing. In that case, client-side service discovery, there is no load balancer in that picture. Instead, there is a service registry. So your connections are direct to your upstream resources, and you have fewer components in your system. But your clients must be registry aware, so there is no single endpoint to connect to and resolve IP automatically. So you need to know how to call the service registry to retrieve these resources. And of course, the client-side load balancing applies in that case. So there are a lot of existing solutions in that space, but All of them require setup and management. And we heard that you guys would love to have a managed service that does exactly that. That's exactly why we introduced AWS Cloud Map. It's a tool to build a dynamic map of your cloud. With Cloud Map, you can define convenient names, friendly names for all your cloud resources. It's not only about endpoints, it's about every single cloud resource that you have. When you're registering your resources, you can define additional attributes such as deployment stage, version, deployment color maybe. And then when you do discovery calls, you can reference these attributes and filter down the result set to get only the resources that you really need. So we do support health checking for IP-based resources. So with that, Cloud Map ensures that only healthy endpoints are returned back to you, so you never route traffic to unhealthy stuff. And of course, you get highly available DNS and highly available regional APIs for discovery. So you get the best of both worlds. You can discover your things over DNS and over API. I will get deeper into these features and use cases in a second. So let's start with a high-level picture of what could be your really simple cloud application. You can have your web server that runs on Amazon EKS with your backend components that run in Fargate mode on Amazon ECS. You have your payments integration application that runs on EC2, maybe an auto-scaling group. And you have your payments DB on RDS, let's say. Also, you can have your shared logs and the Lambda function that processes logs. So you have all these components, and some of these components, well, they need to connect to each other, like front-end to back-end, back-end to payments, payments to database. So how do we do that? With AWS Cloud Map, you can get a friendly name resolution. So you can assign convenient names for all your application components and resolve them at runtime. Let me just walk you through this service registry. AWS Cloud Map has a highly available service registry in its core that allows you to store any type of cloud resources. We have 3 levels of hierarchy. So the top level is a namespace, which is a logical group of resources, of services with common visibility and common resolution type. So under that, you can have services. You can have multiple services within your namespace. Your namespace would be something like cloudmapdemo.com, the examples that I'm going to use in my demo. And the service can be backend.cloudmapdemo.com. That service defines how the service instances are registered in DNS and in the API discovery plane. So your service instances are actual resources with IPs or URLs or ARNs that you connect to. And let's take a look at an example of the API, how we register your resources. First step, in that case, I'm using API and DNS discovery. I'm creating a public DNS namespace. Then I'm creating a service, and I provision a very short configuration for the DNS. I'm using a particular namespace that I just created. Then I'm using DNS description, so it's going to be type A with TTL of 60 seconds. Right after that, I can start registering instances against that service. And I definitely want to provide an IP, but on top of it, I can put some custom attributes. These are absolutely custom. You can put whatever you want. So in that case, I put stage beta, version 1.0, and readiness flag. I'm saying, yes, it's ready. That's how we register IP-based resources if we want to enable DNS resolution. However, some resources cannot be discovered via DNS. Things like your DynamoDBs, like your S3 buckets, that they just don't have IPs. So we have an API-based discovery. In that case, you create a so-called HTTP namespace. You use that API. After that, same steps. Create service. You don't need to define your HTTP config, the DNS config anymore. It just doesn't apply to that type of resolution, and you register your services, and you put whatever attributes you want. In that case, I want to put my ARN, again, with some custom attributes. How we resolve that? So now we have all this stuff stored in this service registry. In that case, I'm using my API discovery plane, and I'm using my discover instances API call with where I supply the name of my namespace. In that case, it's shared, and service name. In that case, logs. I'm getting back all the information that I put together along with health status. You see, it's unknown at the moment. We're not health checking S3 buckets. Alternatively, you can use API-based discovery, let's say for the front-end service that was created in a different namespace that supports DNS discovery. You can do just dig command and get back a list of APs, as simple as that. And of course, you can discover that stuff over APIs as well. No problem with that. And of course, it's really easy to use the attribute-based discovery with AWS Cloud Map. Imagine we have a number of tasks or containers running with a set of attributes that you guys defined. I say stage, version, and readiness flag. When I make my API call to discover instances API, and I supply my stage as a query parameter that equals to prod, I get back just 2 resources, 2 endpoints that correspond to that stage. Or I can say, give me resources for version 1. Or I can combine multiple query parameters and get both, let's say, version 2 and ready yes, the endpoint that corresponds to these parameters. That's how you use the attribute-based service discovery. Easy and intuitive. So what it gives you? Well, obviously, you can work with incremental deployments. You can work with deployments in multiple environments. And of course, it enables smart traffic routing, something that I'm going to touch on a bit later. That's really cool. That's an example of that API call. I supply my query parameters ready equals yes, and yeah, I'm getting just one endpoint that corresponds to that particular query. The next topic I would love to discuss is about handling partial failure. It's really important to make sure that your applications run smoothly. There are no problems, even when some of the resources go down and stop responding. You want to set traffic to resources that are healthy, service providers that are healthy, and can continue serving traffic. So let's say I'm doing my discovery instances API call. I get back 2 APs because both are healthy. And we're using Amazon Route 53 health checks to ensure that resources are healthy. If something goes wrong and one of the resources gets unhealthy, fails, goes down, you just shut it. You stop your EC2 instance. For example, your next discovery instances API call would automatically return only the healthy endpoint. Of course, you have control over that. You can provide additional parameters and get unhealthy resources as well. I'm going to show it later. So what it gives you a way to direct traffic to healthy endpoints. And of course, we have an API that you can use to check the health status of all your resources. That would be an example of that API call. So we start with creating a service that has a DNS config, because we're health checking resources endpoints that reside in DNS. In that case, so we provide health check config, which would be, let's say, type TCP and failure threshold 3. That's the default, how many times the health checker understands or finds the resource unhealthy before it flips the status. Then we register instances and providing IPs and ports. Why we need ports? Because it's a TCP health check. It needs to know which port to hit. And you register multiple instances, let's say healthy and unhealthy. It just gives them convenient names. And when I do, my unhealthy instance points to a fake IP that doesn't exist. When I do my dig command, I just get the healthy resource back, healthy IP back. I can call my getInstance health status API, which returns me the health status of all my endpoints. And alternatively, I can do discover instances call and provide that additional parameter, health status, and say unhealthy. I'll get back unhealthy endpoints. If I say all, I'll get back all endpoints, and by default, it returns healthy only. What it gives you a way to control your traffic, but we also have the custom health checks implemented. It's a kind of cool tool that allows you to start and stop traffic routing to your endpoints at will. So it gives you a reliable propagation of health status to your endpoints. So there is no active health checking happening. It's an API that you can call to say this endpoint is healthy or unhealthy. So you really control when you want to start and stop traffic routing. And when you say it's unhealthy, just to get it clear, it's not removed from our system. It's removed from routing. It's still in our system with all the attributes. You can always access it. You can always figure out what's going on. You can always flip the status back to healthy, so traffic gets back to that resource. But I was talking for quite a long time, and I think it's time to show a little demo. Just give me a quick second. All right, here we go. We're looking right now at the console, beautiful console of AWS Cloud Map. And here I have two namespaces defined, two groups of services. The cloudmapdemo.com, which supports API calls and public DNS resolution, and shared namespace, where I have my just things that can be discovered via DNS, such as Lambda functions and logs. So let's take a look at it. I have my backend payments DB and payments integration application here. These are my services. And let's see what I've got inside. I have my service instances. This is my Fargate deployment, backend Fargate deployment. I have two tasks running at the moment. Both are healthy. Let's say I want to scale up. Let's check my ECS cluster, and I have two running tasks at the moment. Say I want to go and scale up to 4. It still shows 2. It's going to take probably a moment, about 10-15 seconds before they appear. In the meantime, let's take a look at what we get with our discovery. Backend cloudmap.com. And of course, it's cloudmapdemo.com. And we get 2 IPs, so it's not, this change is not yet applied. And if I go and do my discovery call, I get back 2 instances. Just look at that. Just look at the richness of data that you get back with your API discovery. You had your IPs with DNS. Here, you're getting stuff like availability zone. If you use EC2 launch type with ECS, you get your EC2 instance ID. With that information, your client applications can make smart routing decisions, and they can go to applications that sit in the same availability zone. No more cross-AZ calls. That's awesome. And even more, if it happens that your server containers or tasks reside on the same EC2 machine, well, no network calls. It just goes to the local machine. That's absolutely amazing. So now let's double check what's going on with our Fargate cluster. And now we have 4 running tasks. And I would totally expect to get back 4 instances now. And indeed, all that thing is automatically registered for you. No work required on your side. Just enable service discovery when you create your ECS service and point it to a specific namespace. So I have my 4 instances. What do you do with them? Now what I really want to connect to an upstream service in US West 2A. So I supply my parameter, query parameter, availability zone equals US West 2A, and I get back to endpoints that reside right there. Connect to that stuff. Don't go across AZ, which is quite convenient. So that, in essence, the integration between ECS, Fargate, and EC2 launch modes, and the AWS Cloud Map. And it's much better than previous version of the ECS service discovery where you could get back just APs or AP port combinations. Now let's take a look at my front-end service. What's going on? We haven't seen it in the console. Let me describe my Kubernetes cluster, EKS cluster. And indeed, I forgot to just start it up. And why don't we just get it started? I want to spin up my front-end service. Now it's created. And let's describe my cluster. It's right there. So it's going to take about 15 seconds to propagate all the changes to Cloud Map. While we're looking at that, let's look at stuff that doesn't fit DNS. My S3 logs that reside in a different namespace called shared. So we get 2 different instances. One of them is read-only, second one is not. 2 different shards that point to different S3 buckets, both in stage beta. And of course, I can do exactly the same. I can just make a call and say, I want to figure out which S3 bucket with logs is read-only. Here you go. Now let's get back and see if we have all my stuff here. So let's try to discover a front-end service. And here we go. This is my ELB right here that matches the ELB of the load balancer, automatically created for you thanks to external DNS connector that was deployed on that EKS cluster. So EKS automatically publishes ingress controllers to Cloud Map. And of course, you can do a quick dig for front-end cloudmapdemo.com. And of course, it takes a while to get this stuff in DNS propagated. That's one of key advantages of API-based discovery with Cloud Map. It's much faster than DNS. With DNS, you have to deal with change propagation time. With Cloud Map, this change propagation time is much, much shorter. And more than that, you don't have to worry about your TTL. So it's a cashless system. Every time when you make a call, you get back the current endpoint. So let's see if now it propagated. So now we have the IP addresses that correspond to that load balancer. So now we have ECS and EKS integrated with AWS Cloud Map, and of course, we can register any other things. Now let's take a look at our payments processor application. It runs on EC2 instances. And they have 2 IPs. I was confident they have 3. Let's understand what's going on. OK, I have my instance ID I1 and I3. Where is my I2? Health, status, unhealthy. OK, I have one of the instances unhealthy with the instance ID, that little guy. I registered it with that instance ID for convenience, of course. So now I can go and, let's say, describe instance status to understand what's going on. Oops, looks like it's not running. And it's being health checked. So these guys are healthy. They're up and running. This guy is unhealthy. It's not visible in your DNS resolution, nor in your API resolution. Let's try to maybe spin it up. And probably it's going to take a while. Yeah, it was stopped previously. Now it's pending. It's going to take a while. And I have my last piece of the API that I really wanted to show you today. It's my payment DB. Again, I have my little Aurora instance, serverless, of course, that I registered in AWS Cloud Map with a bunch of attributes that I believe are quite important, starting from, obviously, my CNAME, cluster ID, min-max capacity that can help me understand what's going on, with things like version, port, stage. I get the full ARN of that particular database. But also I have links to my configuration that is stored in Systems Manager parameter store. And I have a link to my secret that is stored in AWS Secrets Manager. Now, when I discover that particular endpoint, what I can do, I can probably go and retrieve my configuration for that file. Off we go. That's the configuration to connect to that particular database instance. I won't show you my secret for obvious reasons. While we were looking at that example, I think the EC2 instance is back up and running. But to sum up what's going on here, you can register any cloud resources. You can link them to configurations, to secrets. You can leverage the full power of AWS. You can link it to other services that are meaningful for your use cases and build the applications with less operational overhead and with, well, basically the real full power of AWS. Let's check it out and see if we have unhealthy instances. Oops, no unhealthy instances anymore. Awesome. Let's just get rid of that thing. And we have 3 healthy instances running and discoverable again. Everything is back to normal. I have all my 3 EC2 instances with payments processor application up and running, perfectly healthy. And of course, if I do dig for payments cloudmapdemo.com, I get back 3 IPs. So health checks are integrated with both DNS and API discovery for IP-based resources. So that was my demo for the APIs. And before I go back to slides, I want to address a couple of questions that I heard in the last couple of days. First, does it work with CloudFormation? Yes, it does. Obviously, it does work with CloudFormation. You can register your application in your CloudFormation templates, create services, and off you go. And second, how do I do cross-account calls? That's simple. We provide 4 policies, 4 managed IAM policies. I was saying 5 before. I was wrong. It's 4 that range from discover only to full admin access. So your users can assume these roles, make cross-account calls, and register things in a single service registry. All right, so I guess it's time to switch back to slides. And now let's talk about ecosystem. We have some really nice integrations with AWS, which is table stakes, I guess, but also we have some amazing, amazing partners that work with us on integrating with open source solutions. Let's quickly walk through the internal AWS integrations. Amazon ECS Service Discovery. Now you get up to 8 additional attributes, 6 in case of Fargate launch, because, well, EC2 instances are really abstracted away in Fargate. And you can do smart traffic routing based on locality. You can use external DNS connector for Kubernetes. It's an open source project that we work with the open source community. Some amazing people helped us shape it out. Now you can use it with your EKS to propagate all the ingresses and service information to Cloud Map. Another service that we launched, we announced a couple of days ago, AWS App Mesh. It's a managed service mesh for your AWS applications. It will use Cloud Map and all these attributes that ECS populates to make these smart routing decisions on your behalf. So you don't really have to worry about it. You won't have to build your clients in a special way that really looks up the EC2 instance ID or availability zone. One other project, open source project that we worked on with amazing guys from Tetrate, it's the Istio integration with AWS Cloud Map and with ECS, with Amazon ECS. Now, when you deploy the Tetrate Istio Cloud Map operator on your EKS cluster with Istio installed on top of it, it will query Cloud Map for all the information related to ECS. It will automatically populate Istio control plane, and it will build service entries and routes to all your ECS services. So it's going to look like your EKS cluster is extended to ECS with Istio, which is amazing. The guys from Tetrate, really great. I highly encourage you to go and check it out. Have a nice blog post on that, tetrate.io. And now, the most exciting part of today's presentation. I would love to welcome on stage Mitchell Hashimoto, the founder and the CTO of HashiCorp.
Thanks, Alex.
Mitchell.
Thank you. All right, hello. Let me make sure I have this ready. Cool, so thank you, Alex. As Alex said, I'm the founder and CTO of HashiCorp. We're the creators of Vagrant, Packer, Terraform, Vault, Nomad, as well as Consul. And we're super excited to have been able to work with the AWS team and the Cloud Map team on integrating Consul directly with Cloud Map. So Consul is our tool for distributed service networking covering discovery, configuration, and service mesh and segmentation. AWS let us know that Consul is the most widely deployed service discovery solution on AWS today. And we're excited to provide a solution with Cloud Map for our joint customers. So the challenge that we're facing, as Alex said, is just really the growing number of services. And something that comes along with this growing number of services is that they tend to go in many, many places. So a lot of us adopting cloud are adopting cloud in multiple regions. We're adopting cloud from legacy on-prem infrastructure, and it's usually not an atomic operation, right? Like we still have some stuff on-prem, we still have some stuff in older other regions, and so on, and we really want to be able to talk to all of them as if they're just local. And so one of the primary challenges that we see a lot is Consul is deployed everywhere. It's in all regions of AWS, it's on your on-premise infrastructure, et cetera. And the problem that we're looking to solve is to enable seamless syncing between all of your services, no matter where they're registered, so that if you are in an AWS environment, you could use Cloud Map and the high-level HTTP APIs and DNS that it gives you, along with health checks, to be able to find and route to those things. So in this diagram here, we have AWS US East 1 with Cloud Map, and we're using Cloud Map there. But we also have an on-prem infrastructure that, of course, doesn't have Cloud Map there, and so we've deployed Consul. We also have other data centers. We've marked another on-prem data center 2, and then another AWS region that's running Consul in US West 1. And Consul is multi-region, multi-data center supported out of the box for over 5 years now. And so this is a really common sort of deployment pattern that we see. And our integration with Cloud Map makes this all super, super automatic and seamless. So what I want to hop over to next is an actual demo to show you how this all works, and I'll explain the integration along the way. So unlike Alex, this is going to be a recorded video that I'm just going to voice over to make it simple. OK, so we have the demo up and running here. And I'm going to start by just setting the stage. So we've created a namespace in Cloud Map for a domain hashicorp.live. This is a DNS-supported namespace. We have some instances in AWS that I'll show you. We've set up an on-prem physical bare metal data center as well, and we've already VPN connected those. So we're going to sort of ignore the networking problem here, and we're going to assume that you either have a VPN, direct connect, transit gateways that they just launched, some sort of solution to connect those two data centers together. So let's go through the video. You can see we have hashicorp.live set up, and we also have no services yet. So this is just an empty Cloud Map namespace just to get us going. Like I said, we're setting the stage here. To show you as well, in Route 53, we only have the namespace set up, name server set up. We have no entries, no A records, nothing else in here. Next, I want to show you the EC2 instance we have. So this is us SSH into EC2. We're going to run ifconfig just to show you here. What you could see is we have just a private IP address directly from AWS. And then the crazy interface at the bottom is our VPN already pre-configured directly to our on-prem data centers. And then here, what I have is two bare metal servers that we're SSH'd into. I'm mirroring my typing on both sides, so we could see what's happening in both servers. So when I run ifconfig here, you could see that it's definitely sort of a bare metal server, has its own private IP address, and then at the very bottom, you can see the same network device that is the VPN. What we also have running on these two machines is Redis. And we're going to use Redis as our example service that you want to reach from AWS back onto on-prem. So I ran Redis CLI. Again, on both of them, they're not clustered at all. They're separate Redis instances. But we're just using this as an example where this could be a Postgres database. It could be an API server. It could be Active Directory. It could be sort of anything that you want to be reaching back to onto your on-prem data centers. And this is just showing you that they're running and happy. The other thing that we have in our physical cluster is console already deployed and configured. So we could run console members and see that we have 5 servers. We have the 2 database servers that I just SSH'd into and showed you. And then we have the 3 console servers already alive, running, and then everything clustered together. And you can see those there. The other thing we have set up to finish it up, the last thing, is that we have these Redis instances registered as services with console already. So we've named them DB here, but you can see the port is 6379, which is the default Redis port. And we also have a health check set up, which is make sure that Redis is alive and responding to requests. So this is already there. This is already done. And we could see all this by opening up the console UI. And you can see we have the database service registered, and then the 2 on-prem instances there. So that sort of sets the stage. So what we have so far, just to recap, is we have an empty Cloud Map set up in AWS. We have an EC2 instance that's just running. And then on-prem, we have 2 servers that are running Redis. They're registered with console, and console is only running on the on-prem setup. And they're pretty much fully separate right now besides the VPN connection. So the first thing we do to sync AWS Cloud Map with console is run the console AWS sync catalog feature. Console AWS is a tool, official tool maintained by us that you run to do the syncing process and encapsulates all the integrations that we're doing with AWS. And so it's a bidirectional sync. We'll sync stuff from Cloud Map down to console and from console up to Cloud Map, and you can see that here. You could also run it in a single direction mode if you just want your cloud resources to access your physical resources, but not vice versa. You could run just one direction. And the nice thing about this is it's a completely stateless, separate process. So if this thing crashes, just restart it. You could run it on another machine. It doesn't store any data. If it's down for 5 hours and you restart it, it'll reconcile all your services. It's a really, really easy thing to run. So we're going to start it up here and just run it. We point it to our namespace ID in Cloud Map, start it up, and then pretty much instantly, we could go over to Cloud Map, refresh, and what we're going to see is that our 2 services in console show up directly in Cloud Map. If we click the database, which is Redis that we have, you could also see that 2 services were registered, which are the 2 database servers that we have. So then, if we go over to the EC2 instance, we could use Cloud Map's DNS to see that these show up just there just as if they were just running on AWS. So they show up just like that. And the real power in this is sort of, if you're migrating these workloads into AWS, then when you do it, you've already sort of you're using Cloud Map, you've already set it up. It's invisible to where these things run. It doesn't matter to the end application. They could just easily connect to them. I also use a Redis CLI with that host to show you that we could connect to Redis across the VPN using Cloud Map for the service discovery. It's a pretty neat, all automatic, all really, really fast as well. Okay. So the next thing I want to do is show you how health checks sort of play into this. So we're just going to shut down one of the on-prem servers. We're just going to shut down one of the databases, and this will, of course, fail the health check because it's not running anymore. The first thing we could do is sort of tab over to the console UI and verify that the database now only has one instance rather than two. One of them's gone. And the AWS sync process is built on Console's event system, so it's edge triggered. So right when we did this, there's no polling or anything. Right when we do it, immediately there's only one service registered in Cloud Map. And so the unhealthy one disappeared, and the healthy one is still there. Back on EC2, we could do a DNS query, and we'll see as the results that we'll only get one IP. Just as Alex said, this is subject to the TTLs that you configure with Cloud Map. In this case, it all propagated in time. And then finally, at the end, we use Redis CLI to connect. And because it's using DNS, and because DNS from Cloud Map is just returning the healthy instances, we're able to connect just fine. So what we've done to this point is show you the direction of your cloud resources talking to your on-prem sort of database. And now I want to just show you the reverse path. Okay, so what we're going to do is go back to the namespace and click Register Service. We're just going to do this all manually through the UI, but as Alex showed you, this could just be happening automatically from various AWS services, your own software. This could happen in any way. We're going to register a service called Web. We're not going to do any health checks to keep it simple, but if you do register health checks, we mirror that in console as well. And then we're going to register an instance. So we're just going to name the instance, I believe we name it Web1. And what we're going to do is for the IP address, we're just going to take the private IP address of the EC2 instance that we're currently on. So ifconfig to grab the IP, swing over, paste it in there, make up a port. We don't actually have anything running on the EC2 instance, and then register it. So this gets registered with Cloud Map. And similarly, that syncer is watching Cloud Map, and immediately when you register something, puts it into console. So if we go back to console and go to the index page to list of services, you can see that the web service showed up. One of the really cool features of console is that when we have services registered externally, we put the logo of what registered it right next to it. So it's really clear right here that this is an AWS managed, AWS source service. You could see the cute little AWS logo right next to it. And when you click it, you can see the one instance, the one node that has that service running. And then you could also see at the top, we also tell you that it was registered via AWS. And then the last thing, we're going to go back to our on-prem servers, use dig, point it to the console DNS server, and use the normal console DNS. And of course, that's going to return the EC2 address that we have that we could connect to. Console also returns the key values as text records. That's not super important. And so that shows you both the directions of Cloud Map to console, console to Cloud Map, and then how those could be used to connect sort of one direction or bidirectionally. So that's the demo. Let's move back over here. Cool. Okay, so there's three sort of major challenges, and Alex also alluded to this for how AWS is solving them, and we're working with AWS across sort of all these categories to make adopting service-oriented architectures or microservice architectures much, much easier. The really common cases that we see are service discovery, segmentation, and configuration. As we saw with service discovery, DNS is a really great way to solve that. We've worked with AWS to make Cloud Map great in AWS with console and bridging those together. Service segmentation is really the security and mesh problem. AWS this week launched App Mesh, and we're also working with AWS so that it works seamlessly with console's service mesh feature called Connect. And then finally, console provides KV store for configuring services, and AWS offers a number of services to do this as well. And so that sort of concludes the integration we did with AWS on Cloud Map and Console. We're super excited, but now I'm going to bring Alex back onto the stage to talk about availability and pricing.
Thank you, Mitchell. Well, it was a great, great example of an integration, and we keep working with the open source community, with our partners, to make sure that tools that you use today work with AWS the way you want them. So if you have any other ideas or use cases, please feel free to talk to me, send us an email, and we'll get in touch, and we'll make sure that the tools that you need work with AWS Cloud Map. So our vision for AWS Cloud Map is really to make it the service registry and discovery solution for all your cloud resources and all your workloads. Now let's chat about availability. So now you can use AWS Cloud Map in these 14 regions. It's pretty much global, pretty much everywhere. Go ahead, start using it today. You have both console and APIs available, and all this stuff is up and running right now. Now, a few words about pricing. It's quite simple and predictable. You pay for the resources that you register. It's 10 cents per resource month, and it's prorated. So you register a resource for 1 hour. Guess what? You pay a fraction of a cent for that registration. And for Discovery API calls, you pay $1 per million calls. Of course, if you use other AWS resources, such as DNS, you pay for DNS-hosted zones and queries, and Route 53 health checks if you choose to use them. Well, with that, I think we can conclude our presentation and go to Q&A. And Mitchell, maybe you can join me on stage for the Q&A as well. Thank you.